Hello everyone, this is an experience sharing session of EN2532 Robot Design and Competition where students who have taken this module previously share the experiences and techniques that they used in designing robots. In this video, we would like to highlight some of the basics and advanced techniques that need to be considered when designing autonomous robots. Robotics is a field that combines practices in electronics, computer science, and mechanics to find a solution to make a product that can be programmed to cater different needs. We will give some tips and tricks that we have learned using our journey of building a robot to Sri Lankan Robotics Challenge competition organized by our own department, which is one of the biggest undergraduate robotics competitions in Sri Lanka. Undergraduate robotics competitions are organized locally and internationally to empower robotics enthusiasm, to inspire undergraduates to learn robotics, and to enhance team spirit, team leadership, and project planning. You are given some time period to develop your robot for the competition from the date of the task is released. Most competitions have many rounds to reach the final. Teams have to design a robot to cater a specific given task in their own innovative way. The team which completes more tasks in less time, doing less errors, will eventually win the competition. We would like to highlight some of the robotics competitions in Sri Lanka, such as SLRC, organized by Electronic Club of University of Moratuwa, Robotics by University of Ruhuna, RoboFest by SLIIT, RoboGames by IESL, Digital Dreams by University of Kelaniya. And there are many international competitions as well. Some examples are RoboCon, TechFest organized by IIT Bombay, TechRity organized by IIT Kanpur, and RoboCup competitions. To get familiar with the SLRC task, we will briefly go through it now.
Here we are going to give a brief introduction about the task of the Sri Lankan Robotics Challenge 2019 competition with a short video. In this competition, we had to build 2 robots to complete the task. Those 2 robots should be attached to each other at first, then they should separately function in the middle of the task. At the first part of the task, after dropping the primary robot, the secondary robot had to calculate a value by indicating lines and pillars on the arena. This value was used to select color cells to drop coins inserted in the secondary robot. Here you can see an example value is being calculated. Then the robot has to enter the grid and map all the cells while identifying the color and calculating the relevant indexes of the cells. When the robot found a color cell, it should indicate the color of that cell. After mapping the grid, robot should calculate the order to drop coins according to the instructions given in the task document, and it should drop 3 color coins inserted in it onto the relevant cells. While secondary robot is placing the coins, primary robot should move the box onto the correct color region. Finally, after dropping coins, the secondary robot should exit the grid and attach with the primary robot to enter to the final part of the arena. In there, secondary robot had to identify the colors of the lines, while primary robot was moving the boxes onto the correct regions of the semicircle. A detailed explanation of the task with a full video can be found.
Task planning is one of the major things that our team focuses on when it comes to robotic competitions. Good ideas generated are the key for success. So, when we decide to participate in a competition, the first thing we do is arranging brainstorming sessions to pool our ideas. At first, we all read the task individually and understand what the robots need to do. Then in brainstorming sessions, we individually present our ideas and then merge each other's ideas, and finally we try to make the best possible decision. This optimum decision is mainly based on 4 things. Here we put more weight into the first 2 aspects. First one is reliability. Without reliability, other things are useless. So we first try to think of design plans that can actually perform the desired task as required. Second one is simplicity. Out of the suggested design plans, we choose the simplest one among them. The reason we recommend the simplest method is because it increases the first factor, reliability, because when the design or mechanism is too complex, the failing probability also increases. So our team would like to propose to you all to make simple designs. Third aspect we consider is time, and the last one is the expected cost. But the thing is, when we choose the simplest design, automatically we choose the optimum design plan for these 2 factors as well.